aspiring mathematicians. Today I am going to dive into the unit of rational expressions, and I am going to show you how to divide rational expressions. Rational expression is an expression that can be written as a quotient of two polynomials. You will either have the slash sign or the division symbol, meaning that you will have a polynomial in the numerator and a polynomial in the denominator. Now, if you go back and watch my video, you will know the difference between a binomial, a trinomial, and a monomial. And that is under the umbrella of polynomials. The thing I am going to bring into this lesson is the fact that we should know what a rational number is, and that was the basic concept that was taught to us in primary school, or what we call elementary school, depending on where you are in this world that you're watching this video from. Now, when you think of a rational number is simply a number that can be written as a fraction. And if you even have a whole number such as 2, you can write that 2 as a rational number, which would be 2 over 1. So a rational number is sometimes referred to as a ratio of two numbers, meaning a ratio of 2 and 1. You will notice here that 2 is in the numerator and 1 is in the denominator. And that is what makes it a rational number. Now we can take this concept of dividing rational numbers into the concept of dividing rational expressions. If you go back into your memory box, when you were taught how to divide rational numbers, you might notice that you were given a number, say 3/4, and you had to divide it by 2/3. We are going to use the same concept here, which is to keep, change, and flip. So let's bring that concept into when you're frying an egg or when you're grilling a hamburger. So if you're frying an egg, you're going to keep the oil in the pot, and you're going to change the division, meaning that you're going to change the side of the egg that you're frying, and we're going to change that. So we're going to change that now to a multiplication, division to multiplication, and you're going to flip this part. So you're now going to have 3 over 2. This is coming from when we say keep, change, and flip. We are going to take this same concept into dividing rational expressions. And let's get into our first example. So the first example is x squared over 4 divided by 3x over x minus 5. You will notice here that because we are dealing with rational expressions, you have variables here in each of your expressions. Now you have one side and you have the other side, and we must use the concept of keep, change, and flip. You can apply the concept of you frying an egg, and if you don't like eggs, let's say that, okay, you are grilling a burger. So for this keep, change, and flip, you are going to keep your x squared over your 4, and the next step after you keep the first term is that you are going to change the division sign to multiplication. Because we're dealing with the x here, I don't like to use an x either, but normally you use a multiplication. I'm just going to put a dot right here, and that dot means yes, you're going to multiply. Now you change that. The next thing that you need to do is that you need to flip what you have on the right side. So you need to flip this, and you're going to have now x minus 5 over 3x. Now that we have done that part, we have to look at the expression and see if we can cancel anything out that has a common term or a common number or something that we can find the GCF of, so that we can reduce it. That is the main concept that you must do next after you have applied your keep, change, and flip. So you cannot do anything with the 4 because there is no number diagonally that can go into 4 and nothing on top that can be reduced to this. but you have a 3x here and you have an x to the second power, so you can take away the x here, take away your x from the x to the second power, you're going to be left with x. So your answer here, after you've done this, you now have your x parentheses x minus 5 close the parentheses over 4 times 3, which is going to be 12, and this is going to be your final answer. And I always say to my students, please, please box your final answer. The next example that I want to demonstrate to you is n minus 8 over 4n divided by 8 minus n. You will notice that on the right side here you have 8 minus n, and it is not written as a rational expression because it is just written as a expression here. In order to get it as a rational expression, you have to apply the same concept as what you would have done if you had a number 6, which is a whole number, and to write it as a rational number, it would be 6 over 1. So we are going to still apply our concept of keep, change, and flip. Do not forget that. KCF. Not KFC, but if you want to think of KFC, finger licking good, and apply that concept, but just remember, it's not the F before the C, it's the C before the F, just as you see here. Alright? So we are going to keep our first expression here, rational expression, which is the n minus 8 over 4n. And the next thing you are going to do, you are going to change that sign. Now, because I'm not working with any variable that is x, I'm going to use my multiplication sign. So that I want to highlight to you. And the next step that you're going to do, you're going to put the 1 over 8 minus n. Guess what? There's something that I must tell you about this 8 minus n and this n minus 8. If you look at these two factors, you will notice that they are the additive inverse, meaning they are opposite. You have n minus 8 and you have 8 minus n. The proper way to write any expression in the standard form is to have your variable first and then your monomial constant, which is a number that stands alone following any variable that you have or any term with variables. So in order to change this 8 minus n, you are going to simply factor out a negative 1. So if I have my 8 minus n here and I need to change that to n minus 8, I need to take out a negative 1 out of that. If I do that, then I can have my n here and my minus 8 here. And you can test this, and I'm going to show you, alright, that it will work. Multiplying that out, you will have negative n. Multiply your negative 1 times the negative 8, you will have positive 8. Now, you have it like this, right? And this is basically when you change this around, reverse this, put this over here, you have the 8 minus n, which is taking you back to the original here. So in this concept, we have it written as this, but your next thing that I want you to do, and I'm going to keep that line, is that I want you to rewrite it now where you have your n minus 8 over your 4n times 1 over negative 1 parentheses, then you have n minus 8 here. You must do this. Notice it's coming from this, you're just switching it, taking out your negative 1, factoring that out so that you can end up having the two factors looking the same. And that's only because you have the factors looking pretty much the same, but they're not exactly a match. So now they are literally a match. As an extra practice, right, if I gave you, say for instance, x minus 2 over 2 minus x, you'll notice that they're almost the same. All you have to do is simply change this now and have x minus 2 over negative 1. You take that out and you have x minus 2 here, and then you will be able to cancel these two out because they are a match now. So you have to do that when you are dealing with any expression that looks almost like a match but it's not exactly a match. We call it the additive inverse, right? And so you have to take out your negative 1, factor it out so that it can look like a match. So now that you have that part, we can go ahead now and we can cancel out what is able to be cancelled out. So that n minus 8 is cancelled out with the n minus 8 here. You are left here with 1, right? Because it cancels out to just 1. And then if you continue, you will multiply 1 by 1, which is going to be 1, and over 4n times negative 1, which is going to be simply, you can write it like this, negative 1, negative here, we're not going to do the 1 because we're multiplying negative 4n. That could be your answer, right? Or you can write it in this format, negative 1 over 4n. So either one is acceptable. Put the or there so you know that either way your answer is correct and it is acceptable. As you should know by now, I like to give various examples. Variety is the spice of life, and not all the time you are going to be given simple expressions like this to factor out, or let's say to divide, because that is what the topic is about, how to divide rational expressions. So let's get into a more tedious example and show you what to do when you have quadratics going on, meaning that you have trinomials going on. If you have trinomials going on, you have to factor out the trinomials first, and then you have to reduce where possible. So let's get into our next example. So our third example is going to be x squared minus 9 over 2 divided by x squared minus 2x minus 3. Now you will notice that you have a trinomial going on here, and you will also notice that you have difference of squares. So if you don't remember how to factor out difference of squares, you can go back and watch my video on how to factor out difference of squares. And if you don't know how to factor out a trinomial, you can also go back and watch my video on how to factor a trinomial, and that will guide you. But in this event, I am going to go ahead and factor them out for you. So you have your x squared minus 9, which is a difference of both squares. So because you have that, you're taking the square root of x squared and the square root of 9 right there. So you will end up with two sets of binomial. One is x minus 3 and the other one is x plus 3. And put that over 2. We are going to use the same concept here because we are dividing, and we are going to change that division symbol to a multiplication. But I hate to put the multiplication sign here because we are dealing with the variables x, but you can just put a big dot. Don't put a tiny one. Make it be obvious. So once again, this is going to be over 1. You have to write it as a rational expression. Over 1 to make it rational. If it is not over 1, it is not rational. So once you do that, you put your 1 at top because you're flipping it. Remember, you have to use the concept of KCF, which is keep, change, and flip. So you have your 1 now over the next expression or trinomial, which is x squared minus 2x minus 3. You notice here that you have your negative 3 at the end. So because you have negative 3 here, one of your factors is going to be a positive number and the other one is going to be a negative number. So it's going to be x minus 3 and x plus 1. Now that you have this written out, you have to look at your binomials that you have, or look at your terms and see what can be cancelled out. You notice you have an x minus 3 here and an x minus 3 here. So that off the top can be cancelled out. So you're going to cancel out this with this. And you're going to be left now, you have your 1 there because when you cancel that out, you have your x plus 3 over 2 times 1 over x plus 1. I always tell my students, please write it out like this. The next thing that you're going to do is that you're going to multiply across, so you will end up with x plus 3, and this will have 2 parentheses, x plus 1, close the parentheses. You have a choice. Leave your answer like this, or you can do this. But I always prefer to tell my students you can just leave your answer as this. You can go back and watch my videos if you need help on factoring out those types of expressions. Now, as you know, I have to take it to another level. Yeah, take it to the top. Level up, level up, level up, level up, level up. Yes. Take it to the top, take it to the top. Not all the time you will end up with the difference of perfect squares to factor out when you are dividing rational expressions. You could also be given a quadratic expression to factor out whereby a is greater than 1. So my next example is 10x squared minus 17x plus 3 over 5x squared plus 4x minus 1 divided by 4x to the second power minus 9 over 2x squared plus 5x plus 3. In this example, we have trinomials where a is greater than 1, and also we have the difference of perfect squares where also the a in that sense is also greater than 1. So the first thing we have to do is that we have to first factor out all of the 4 expressions here, and then we can proceed with doing our keep, change, and flip. So first and foremost, I always tell my students, let's do the flip first so that you don't forget to do it after you've factored each one of them out. So you can do that, or if you feel comfortable, you can actually factor out this part. When you get to the change, you change that and then you flip. So we have our 10x squared minus 17x plus 3. In order to factor this out, if you need some help on that, you can go back and watch my video on how to factor a quadratic expression when a is greater than 1. So off the top, we can go ahead and factor this out. And in order to factor this out, I'm just going to go ahead and write what it is. And we have 2x minus 3. And then because we have the 2x minus 3, the next portion is 5x minus 1. Alright, and you can test it. This would be 10x squared if you multiply using the FOIL method. This would be negative 15x, and then you have negative 2x, which would give you the negative 17x, and negative 3 times negative 1 would give you the positive 3. So that is fine right there. Alright, now the bottom part, we have to factor this out also. Once again, watch the video if you need help. So we have 2 sets of factors here. We have 5x minus 1 as our first factor, and the other one is x plus 1. We can test it. This multiply using the FOIL method is going to give you 5x squared. You have 1x and 5x positive, so you will end up with positive 4x, and negative times positive negative 1. Now you must, and I say it again, you must go ahead now and you're going to change this to a multiplication sign. If you want to use a big multiplication sign, go ahead and do so. Otherwise, you can just use the dot if you want to use the dot. It's your choice. Alright? But I don't want you to be confused with the x in each of the expressions there. So we change that. We now have to flip it. And don't forget, this is a part that I don't want you to forget. You have to flip. So I'm going to put F here to flip. Flip it, flip it, like a flipper ball. You know that song? Flip it, flip it, flip it. We are going to have our difference of perfect squares under the bottom, and that is going to give me the finding the square root of that. You're going to have 2x, and finding the square root of 9 minus 3. 1 is going to be negative, 1 is going to be positive, and that is what it is going to be. And then you have the other quadratic there where you have to factor that out also. And for that quadratic, you are going to end up with 2x plus 3 and x plus 1. And you can test it. 2x times x is 2x squared, and 2x times 1 is 2x, and this would be 3x, so that's 5x in the middle, and then 3 times 1 would be 3. So that's what you have. So you're not done. Yes, you did a keep, change, and flip, but as I always say to you, you have to continue. You're not done. Look for any expression that, or any binomial in this case, because we have binomials here that we're dealing with. We're not dealing with any monomial or any whether it's monomial constant or whether it is a monomial term. We're not dealing with that. These are just two sets of binomials. So we notice here that we have a 2x minus 3 and a 2x minus 3 here. We cancel that out. Make sure you're putting your 1 above, right? And the next thing that we can cancel out is going to be our 5x minus 1. We have 1 here. One thing I must say to you is that not all the time you're going to cancel out diagonally. It could be just something from above with something from below. And that is called just reducing or getting rid of, meaning canceling out. So you can only cancel out two ways: diagonally or vertically, meaning something from above and something from below. You cannot cancel out horizontally, meaning you cannot cancel out the x minus 1 over here with if you had an x minus 1 here. No, you would not have been able to do so. So please don't make that mistake. It must only be diagonally or vertically. All right, so we have that. The next thing, we are going to look at what we have, and we notice that we have a 2x plus 3 here and a 2x plus 3 here. We cancel that out. We are left with 1. And guess what? We have an x plus 1 here and an x plus 1 here. If you were paying attention, you'd have noticed that I forgot to put the 1 here and the 1 here. I just don't want you to cancel out and just not put the 1 there, because some students might want to say to me, oh, it's nothing. But guess what? It is something, because it's a 1. So when you look at this now, you have 1 times 1 is 1 here, times 1 over here, over 1 times 1. And I'm doing it this way for students who are not strong in math, to show them where that answer is coming from, the correct answer, which would be 1, and don't tell me this will just give me 0. No, because it's cancelled out. No, that would not be the correct answer. And 1 times 1 we know is 1, and 1 over 1, again I'm breaking it down for those students who don't know, and the final answer is simply just 1. Voila, not 0. So please guys, don't make that mistake and tell me, oh, guess what, miss, because I cancel out, then I have nothing. It's simply using a factor into a factor, and you get 1. It's like saying 3 divided by 3 is 1. Alright? Now 3 divided by 3 is 0. No. With that being said, I hope that this video has helped you tremendously. And now that you know how to divide rational expressions, you will go ahead and apply all the techniques that I have laid out for you in this video. Don't forget, if you have two factors that are the additive inverse, meaning that they look close like they want to be a match but they're not really a match, don't forget to factor out your -1 and rearrange it so that it is looking like a match with the other factor that you have. If you don't do that, your answer is going to be incorrect. So in conclusion, I hope that this video has helped you tremendously, and now that you know how to divide rational expressions, you will be versed on this and you will be successful in your next math problem that is given to you. I hope that you will also go back and watch the videos that I have, whether on factoring difference of perfect squares, or if it is factoring a quadratic expression where a is greater than 1, then you must watch those videos to help you to be better at doing these type of problems. This is all about building on your foundation, and that's why you learn certain concepts first, and then you take that concept into higher level mathematics. Just like when you dealt with rational numbers, meaning that you were dividing a fraction by a fraction and you still had to do the keep, change, and flip, the same concept is being applied here for rational expressions. Because ultimately, if you don't change that division sign to a multiplication sign, and if you don't flip that last term or the second term, or I should say the second expression, rational expression, you are going to get your answer incorrectly. Last but not least, if you are canceling out two binomials that are the same, remember you must put your 1 on top and below to show that yes, this binomial into this binomial goes only one time, and the same thing for the bottom part, which is in the denominator. If you don't do that, you might be tempted to tell me that the answer is 0, which is not, because it's cancelled out. So please remember, cancelling out and they're the same, 1. And that is the reason why your final answer here for this particular problem is 1. So with that being said, if you like what you see and you have not yet subscribed, what are you waiting for? Go ahead and hit that subscribe button. And if you're really, really, truly not a selfish person, please go ahead and share this video with others around the world so they too can learn how to divide rational expressions. And guess what? Leave me a comment. I like to read your comments. And don't forget, hit that like button. And see you soon on the next video to come. Bye now.